Hey, what's up guys? This video is for section 5.1, which is solving inequalities by addition and subtraction. So first, let's go ahead and understand what is an inequality. So inequalities tells you if a number is greater than, less than, or equal to another number. Now, when you guys want to solve an inequality, you guys will have something like this, and it looks very similar to an equation, but it won't have an equal sign. It's going to have an inequality. Now, what are the inequalities? Well, this is one of them. You guys have less than or equal to with the little line on the bottom. If you look down here on the screen, you guys also have a regular less than, greater than, the less than or equal to, or the greater than or equal to. So those are the four options for inequalities that we have. Now here, we want to solve an inequality, and it's just like solving an equation. We're going to do the same steps. We want the same goal. We want the variable by itself. But we have to be careful with the inequality because we're not going to have a regular equal sign. It's going to be one of those less than, greater than, less than or equal to, or greater than or equal to inequality. So if you notice here, x plus 2 is less than or equal to 6. Well, if you guys look at the x here, we want to get that by itself. And then when we have this by itself, which means we have to get rid of this 2, we need to understand what the inequality means. So we'll do that in the example, but first, before we actually do one example, I want to show you guys something that we're going to use for our answer. When we write down our solution, we are going to use what is called a set builder notation, or you can say set notation. A set notation is when you guys have the brackets here, and we have the x's inside with the vertical line in between. So if you notice here on your solution, this is a set notation. We have x, and the vertical line here means such that x is greater than or equal to the number, or you might have a less than, or you might have a less than or equal to. It just depends on the inequality. But that's how you read the actual set notation. You guys have x is such that, that's what the vertical line means. And then we say what x is. Well, in this case, we are saying x is greater than or equal to some number. So this x value is greater than. Also, when we start solving inequalities, we can actually make our graph of a solution, of our solution. And that's what we're going to do as well today when we are going to graph. And when we graph our solution, we need to use an open or a closed circle for the graph. Some people say dots, open dot, closed dot, same thing. But the graph is going to be on a regular number line. So this is where you also have to understand the inequality that you guys have. If you have a less than or a greater than, that's going to be an open circle. If you have a less than or equal to, or a greater than or equal to, you're going to have to put a closed circle on top of the number of your solution. So it's either open or closed. Now, what does it mean, open or closed? Well, when you have a solution, and let's say that we have x is greater than 3, what that means is, well, our solution, our graph is going to be open because we have a greater than 3. And if you understand the inequality, we are saying that x, we don't know what the number is, but we know that that number has to be greater than 3. Now, what numbers are greater than 3? When you guys look at the number line, and I'm just going to put the number line right here. There's the 0, here's the 1, 2, 3. So any number greater than 3 is your solution. Now, how many numbers are greater than 3? Well, there's lots of them. You guys have the 4, the 5, the 6, the 7. If you guys want to be more specific, 3.1 is greater than 3, 3.2, 3.3, 3.5. 100, 1,000, all those numbers are greater than 3. So when we have that open circle, it means that 3 is not part of your solution. Because if you put a 3 here, 3 is greater than 3, that's false. So the number 3 doesn't work, but anything greater than 3 works for that inequality. Now let's say that you guys have a less than. So if we have x is less than or equal to 10, Well, think about it. What numbers are less than 10? Well, the 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Negative numbers, negative 1, negative 2, negative 3, negative 4. All those negative numbers are less than 10. But it has that or equal to part. So if you put a 10 here for the x, so I'm just going to put a small 10 on the bottom. So let's say 10 here is less than or equal to 10. That's true. It's not less than 10, but they are equal to. So 10 is equal to 10. So your answer 10, which is the solution, also works for the answer. So 10 or less, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, all the way to the negative numbers. So that's when we need a closed circle. We're going to need that on top of our graph of the number, because closed means you're including the number in your answers. Open circle, you're not including that number in your answers. So first, let's look at how to graph the inequalities. So I'm not solving yet, but I just want to know how to graph those inequalities. So let me start with this one on the left side. X is less than 4. So first of all, we know that x is by itself. So on the left side, we don't have any number next to the x. We're not adding anything to the x, so that's by itself. But we do have x is less than 4. So look at the inequality right here. So this inequality tells you that the circle that we need is open, first of all. So you go to the 4 on the number line. I do have a number line here, and I make an open circle. When the inequality here is pointing to the variable, that means that, notice the inequality is kind of like an arrowhead, it's pointing to the variable. That means that you guys will have your answers to the left side of the 4. So think about it. X is less than 4. What numbers are less than 4? The 3, the 2, the 1. So all these numbers, 1, 0, negative 1, negative 2, and it goes to negative infinity, are the answers. So any of those numbers actually work. So we're going to use an arrow to show what numbers work for that inequality. And remember that the number has to make sense, the inequality has to make sense. So I am going to draw an arrow from the open circle to the left side all the way down. And I'm saying that all those numbers to the left works for those inequalities. So look, think about it. If you put a negative 5 here, negative 5 is less than 4, true. If you put a negative 1 here, negative 1 is less than 4, true. If you put a 2 right here, 2 is less than 4, true. And if you put a 4 right here, 4 is less than 4, not true. That's false. That's why it's open, because this is telling you that this number is not included in your answer. Now look over here, 5. 5 doesn't have the arrow over here. So 5 is less than 4, false. It's bigger. So 5 doesn't work, 6 doesn't work, 7 doesn't work, and everything else after the 8 doesn't work. So the arrow has to be to the left. Now this one here, you guys have a negative 3 is less than or equal to x. Now one thing that we can do when we have inequalities is we can change the x to the left side of the inequality. But when you guys do that, you have to change everything. You have to flip everything in that inequality. And this is what I mean. If we take the x to the left side right here, I'm going to have to change the inequality. I'm going to have to flip it like this, and then I'm going to bring down the number, negative 3. You don't change the sign of the number, but you bring it down. You can do that, but make sure that you always, if you flip your answer, you also have to flip the inequality. So this less than or equal to becomes greater than or equal to. Now x is on the left side, that's more common. And notice that negative 3 is right here on the number line, and we have or equal to. So what that means is I am going to have a closed circle on top of the negative 3. Now you also have to understand what direction the arrow is going to go. So the inequality is pointing, look at the arrowhead, is pointing to the number. When that happens, the inequality is pointing to the number, then the arrow is going to go to the right, like this. If the inequality is pointing to the variable, then you go to the left. The arrow will go to the left. But right now, the arrowhead, the inequality is pointing to the number. Even if you guys look at this one, the inequality, look, is pointing to the number. so we go to the right. So it means negative 2 right here, if you plug it in, negative 2 is greater than or equal to negative 3, true. 0 is greater than or equal to negative 3, true. 4 is greater than or equal to negative 3, true. 5, true. If you plug in a negative 3, negative 3 is greater than or equal to negative 3, true. It's not greater than, but it is equal to negative 3. So that's why we need a closed circle, because we're saying that this number, negative 3, works for the inequality. All right, so now we're going to start solving the inequality, and after we get our solution, we are going to start graphing our solution. So first we need to solve. Solving means to get the variable by itself. So I'm looking at this inequality here, x plus 6 is greater than 10. Notice x is on the left side. You guys can do the same thing as equations. I like to put a line under the inequality. I want to get rid of the number. I want x by itself. So I'm going to do the opposite, the inverse operations, just like equations. You can do the opposite. So I'm going to subtract 6 from both sides right here. So when I subtract, this cancels. So I bring down the x. And on the other side, we get 4. 10 minus 6 is 4. Now, we don't have an equal sign, but we do have an inequality. So I'm going to put x, bring down the inequality, greater than 4. Now, our set notation, the way we write our answer, will be with brackets like this. You put x is such that, there's the vertical line, so we're saying x is such that what? What is x? Well, x has to be greater than 4. You guys just copy down what you guys got when you saw 4x right there. So x is greater than 4. So that's the actual answer. X is such that x is greater than 4. But now we need to graph the solution. So this is where you guys will use a number line. So here's my number line. I'm going to put the 0 kind of on the left side right here because I need space to the positive side. When you guys graph, we don't need to put the units at once. You guys can, but you don't have to. So I'm just going to estimate. I'm going to say 1, 2, 3, 4 is right here. And I need to pay attention to my inequality. This inequality means open because we don't have the little line on the bottom. So I'm going to have an open circle right here. And notice the inequality is pointing to the number. So we're going to draw an arrow to the right side. So that arrow tells you that the numbers on the right side of 4, the 5, the 6, the 7, the 10, 100, 1,000, 1 million, they're all greater than 4. So that's my graph. Okay. Now let's look at this one here. You guys have an inequality. Negative 5 is greater than or equal to 7 plus y. So first I am going to put my line under the inequality here. I have the y on the right side right here, so I need to get rid of this number, that constant. It doesn't have a variable. So I am going to subtract 7 from both sides. I do the opposite. So when I do that, I get negative 12 on this side, negative 5 minus 7. On the other side, you guys can cancel the 7s. 7 minus 7 is 0. So you guys bring down the y. Now, when you guys bring down the inequality, negative 12 is greater than or equal to y. Now, you guys can also flip your answer. Y is on the right side right now. Look at this one here. So you can flip your answer, but remember that if you flip your answer, you also have to flip the inequality. So another way to write down our answer, or you can say y flip the inequality is less than or equal to negative 12. Make sure you guys do that if you flip your answer. So that's my actual set notation. Y is less than or equal to negative 12. What numbers are less than or equal to negative 12? Well, less than, we have negative 13, negative 14. All those numbers are less than negative 12. On the number line, you guys will have the 0 right here. I'm going to say negative 12 is right here. I'm just going to estimate. And we do need a closed circle because we have or equal to here. So you're going to make a closed circle and look at the inequality. It is pointing to the variable. The arrowhead, the inequality is pointing to the variable. So you guys are going to make an arrow going to the left. So that means that all those numbers on the left side of the negative 12, negative 13, negative 14, negative 15, negative 20, all those numbers are less than negative 12 or equal to, well, this number is included. The 12, negative 12 is included because it's equal to negative 12. And the next one, you guys have 6x plus 5 is greater than 7x. Now this one, you guys have variables on both sides. So first, we need to get the variables on the same side. So I'm looking for the smallest variable, the x term. 6x is the smallest one. So I'm going to do the opposite. Minus 6x here, minus 6x over here. So when I do that, I can cancel the 6x. I bring down the 5, and 7x minus 6x is 1x. So you guys bring down the inequality. I have the 5 right here is greater than x. Now you guys can flip the x to the left side. You can flip your answer, but make sure you guys also flip the inequality. So you can also say, or x is less than 5. Notice I changed the inequality. X is on the left side. Now, my set notation, remember that we use brackets like this right here. I have x is such that, and I copy down all of this right here, which is x is less than 5. And I just noticed that in the previous example, I didn't use set notation, so I'm going to do that right now. Let me just go back. So this one here in the middle, our set notation will be brackets y is such that y is less than or equal to negative 12. So that is my set notation. Over here, we have x is such that x is less than 5. Now that's the set notation for our answer right here. The graph, you guys have a number line, and I'm going to have the 0 here. Positive 5, I'm going to estimate that is right here. Doesn't have to be perfect, but it's on the right side of 0. I need an open circle because I don't have the little line on the bottom here. So I'm going to have my open circle, and notice inequality is pointing to the variable. So that means I need an arrow going to the left. So let's try a few more here. We want to solve the inequality, and then we want to graph our solution. So the first one is n minus negative 6 greater than or equal to negative 3. So first of all, I'm just going to put the line under the inequality. I notice that here I have a double negative, a negative n minus a negative 6. So that would turn into a positive, double negative. Turns into positive. So I put n plus 6 on this side and negative 3 on the other side. Now I'm going to get n by itself, so I'm going to subtract 6 from both sides. This will cancel. You guys do the opposite inverse operation. And on the other side, negative 3 minus 6 is negative 9. Now I do bring down my inequality, so n is greater than or equal to negative 9. Now this one's okay because n is on the left side. So my set notation will be n is such that n is greater than or equal to negative 9. That's my answer. And my graph, I'm going to have my number line, and I'm going to say 0 is here, negative 9 is right here, it's on the left side of the 0. I need a closed circle because we have or equal to in the inequality, the line on the bottom. So that'll be closed circle, and you guys need the arrow going to the right because the inequality is pointing to the number. This arrowhead is pointing to the negative 9. Now when you guys have fractions, same thing as before. So just like equations, you can get rid of the fractions and then you guys start solving. So here, to get rid of the fraction, I'm going to multiply by the denominator, and the denominator on the fraction is 4. So I am going to multiply this by 4, this one by 4, and this one by 4. So you guys multiply everything by 4. So I will have 4b right here, b times 4, plus 2 times 4 is 8. On the other side, I can cross simplify the 4s. They turn into 1, and I just bring down the 3. Now, you guys are going to subtract 8 from both sides. Just like in equation, you want to get rid of the constant. 8's cancels. So we have 4b, and on the other side, negative 5. And then you guys are going to divide by 4 right here. So this turns into 1. B is negative, and you guys cannot reduce the fraction, so it's going to be 5 over 4. So that means that B is less than negative 5 over 4. I bring down the inequality, and that's my answer. My set notation will be B is such that B is less than negative 5 over 4. So that's my set notation. We know that B has to be less than that number, negative 5 over 4. Now to show our graph, I'm going to do my number line. And we have to be careful because we do have a fraction here. So when you guys graph fractions, if you want to turn them into decimal, that's okay. I know that sometimes a lot of people understand decimals more than fractions. So if you guys want to do that, it's fine with me. I'm going to put the 0 right here, and negative 5 over 4, if you do it in the calculator, your decimal will be negative 1.25. So I'm going to put a negative 1.25 right here. Now one more time. This decimal is negative 5 over 4. 4 goes into 5 one time, and you guys have a remainder of 1, so it's negative 1 and 1/4. That's your mixed number. But your decimal is negative 1.5. So a lot of people understand that number better than the fraction negative 5 over 4. So it's okay if you guys use fractions. I need an open circle right here because we have less than, not the or equal to, and your inequality is pointing to the variable. So I am going to make the arrow going to the left. This is showing that the answers, many answers, all the numbers that work for the inequality are on the left side of the negative 1.25. So negative 2, negative 5, negative 10, negative 13, and all the way to negative infinity. Now, if you guys have different denominators, well, to get rid of the fraction when you solve, you multiply by the lowest common denominator. So here, I'm going to multiply by the lowest common, and the lowest common is 6, because 3 goes into 6, and 6 goes into 6. So I'm going to multiply this by 6, the x by 6, and this fraction by 6. So I know that 3 goes into 6 2 times. Let me put the line under the inequality. And I'm going to multiply 2 times 2 is 4. On the other side, 6 times x is 6x. And then you guys can cross simplify the 6 right here, and you bring down the minus 1. So now you guys start solving. I'm going to add 1 to both sides right here. So this cancels. 4 plus 1 is 5, and I have 6 on the other side. You guys can divide by 6 right here. So we get 5 over 6. You guys cannot reduce that fraction. Bring down less than or equal to x. Now you guys can also flip your answer, but remember that you have to flip the inequality. So you put the x over here, flip the inequality greater than or equal to, and then we have 5 over 6. So my set notation will be x is such that, and notice I'm using brackets, x is such that x is greater than or equal to 5 over 6 right here. So that's my set notation. Now for my graph, remember, sometimes it's hard to understand fractions. So if you turn it into a decimal, it might be a little bit easier to graph it. So here, I'm going to have my 0 right there. 5 over 6 as a decimal is 0.833333, and it keeps going and going and going. So 0.833 is less than 1. So I'm going to put 1 here just to make a point of reference. And 0.8333 is going to be around right here. 0.8333, and it keeps going and going and going. It repeats. The 3's repeat. So that's the decimal form for 5 over 6. And we need a closed circle because you guys have the or equal to on the bottom. And the inequality is pointing to the number. Notice inequality pointing to the number. So we are going to have the arrow going to the right. So that's my graph. You guys have the set notation and your graph. Now something else that you also have to know is phrases that represents an inequality. So I'm going to give you guys a couple of sentences and we are going to translate those sentences into an inequality. So notice here that this inequality less than, well, if you see this keyword less than or words, you're going to use that inequality. Fewer than means less than. Greater than, right here, more than is greater than. So we can use either or. Less than or equal to, we can use at most, no more than, less than or equal to. And this one, greater than or equal to, at least, no less than or greater than or equal to. So let's go ahead and try it. I'm going to give you guys a couple of sentences and we're going to translate them into inequalities. So notice that we have two sentences. The sum of a number n11 is no less than 20. So we want to write the inequality, and after we write the inequality, we want to solve that inequality. We're not graphing, but we want to solve. We want to know what is x, greater than, less than, or whatever we get. So first, let's make sense of the problem. Let me just zoom in here to the first one. And it says here the sum of a number. So we know that we have the sum, so that's going to be adding, and a number, so I'm going to use m for the number. So the sum of a number n11 is no less than, right here. Those keywords, no less than, means greater than or equal to. And then we have no less than 20. So we're not going to have an equal sign, we're going to have an inequality. So I'm going to start with the greater than or equal to. No less than, right there. So that's what it means. I'm going to have the sum. So I have plus the sum of the number m and 11 is greater than or equal to no less than 20. So that's the inequality. But now we just want to solve the inequality. So I'm going to get m by itself. I'm going to subtract 11 from both sides right here. So I'm going to have m, bring down the inequality. This cancels right there. And we have 20 minus 11, 9. So we have our answer. Our answer is m is greater than or equal to 9. The set notation will be m is such that m is greater than or equal to 9. So we can say this is our answer, our set notation. We translate that sentence into an equality, and we got the answer. Now the next one says 11 is at most a number decreased by 8. So we know that we need 11 and is at most. So the key words at most means less than or equal to a number. So for this one, I'm going to use the number, I'm going to use p, and we have decrease, so that's going to be minus, you decrease, you subtract 8 by 8. So let's start with inequality. We have at most, less than or equal to. There's the inequality. We have 11 on the left side of at most. 11 is at most, it's less than or equal to the number p, decrease minus 8. So now you guys can solve. We can add 8 to both sides right here. You can cancel the 8s. So you have 19, bring down the inequality, less than or equal to p. Or you can say p is greater than, you have to switch the inequality. If you switch your answer, greater than or equal to 19. And the set notation will be p is such that p is greater than or equal to 19. So that's my answer in set notation right here. We got our inequality right here. 11 is less than or equal to p minus 8, and we solve. Alright guys, this concludes my video for this section. If you like my videos, you can hit that like button. You can also subscribe. Make sure you guys practice, and I'll see you guys later.